1.6 The Product and Quotient Rules for Derivatives. Southwestern College, Professor Maria Olivas. The product and quotient rules for derivatives. Objectives. Use product and quotient rules to determine derivative functions. Solve applications using these differentiation rules. 1. The product and quotient rules. These rules are very important and we should memorize these. We're going to start off by dividing this section that I have boxed off here for the product and quotient rule. I'm going to put in 3 more horizontal line segments to divide this section or partition this section into 4 parts. I'm going to show 2 different versions for each one of these type of rules. They still represent the same rule, it's just a different way to write it. I left the middlemost line segment in the color black, and then the ones that partition just the product rule section into 2 sections, I made that a light blue, and also the quotient rule one, I've made that a light blue. The product rule. The derivative with respect to x of f of x times g of x is equal to f prime of x times g of x plus f of x times g prime of x. Another way that we can consider this rule, just a different alternate form that we could write it in, would be the derivative with respect to x of u times v is equal to u dv plus v du. The quotient rule. The derivative with respect to x of f of x divided by g of x is equal to, in here we're going to have a fraction. In the numerator, we're going to have g of x times f prime of x minus f of x times g prime of x. All over, we're going to have inside square brackets g of x, and then outside of the square brackets, we're raising that to the second power. And in the last partition that we have here for our rules, we're going to have the alternate form of the quotient rule, which is the derivative with respect to x of u divided by v is equal to, once again here I'm going to write a fraction. In the numerator, we're going to have v du minus u dv all over v squared. I'm going to highlight the words, memorize these, and I'm going to highlight around the entire box that contains the product rules and the quotient rules that I wrote here. Example 1. Find the derivative using 2 different methods and confirm they are equal. Here we have the function y equals, inside parentheses we have 3x squared minus 5, and we close the parentheses there. And then times, open up a set of parentheses, 2x plus 7, close the parentheses. Our first method is going to be to multiply out first the 2 binomials. So if we multiply 3x squared minus 5 times the quantity 2x plus 7, we will end up with the function y equals y equals 6x cubed plus 21x squared minus 10x minus 35. Now if we take the derivative of this function, we're going to get y prime equals 18x squared plus 42x minus 10. I'm going to box in that function. I'm going to box in that derivative. Now I'm going to draw a vertical line segment separating the 2 methods that I'm doing here. So on the left-hand side, we had the multiplying out first section, or the multiplying out first method. In the right-hand side is going to be our second method. We're going to use the product rule. So I wrote down the function u equals 3x squared minus 5 times the quantity 2x plus 7. And I have labeled the first binomial as u and the second binomial as v. Next to that, I have written out the product rule, the second version that I had written earlier, y prime equals u dv plus v du. So y prime is going to be equal to the binomial 3x squared minus 5 times 2, which is the derivative of our second factor, plus 2x plus 7 times 6x, which is the derivative of our first factor, that 3x squared minus 5. If we simplify this, we're going to get y prime is equal to 6x squared minus 10 plus 12x squared plus 42x. And if we simplify this further, we will end up with y prime equals 18x squared plus 42x minus 10. I have boxed in that derivative, and I have drawn an arrow pointing at each of my two derivative answers so that you can see that we got the exact same answer, and I wrote down the word same answer next to my arrows here. Example 2. Find the derivative in simplest form. P of x equals 5x plus 7 over 3x minus 4. So our numerator here is going to get labeled with a u. I have drawn an arrow pointing towards the numerator on the left. I have drawn an arrow pointing towards the numerator on the right-hand side of the function. And I have labeled the numerator as u. I've also drawn an arrow pointing towards the denominator on the right-hand side of the function, and I have labeled that denominator as v. I have written down the quotient rule, dx, or the derivative with respect to x of u divided by v, is equal to v du minus u dv all over v squared. Therefore, p prime of x is going to be equal to, we're going to have the binomial 3x minus 4 times 5, which is the derivative of our numerator, minus 3, which is the derivative, the 3 is the derivative of our denominator, times the binomial 5x plus 7, all over the quantity 3x minus 4, quantity squared. If we simplify this, we will end up with p prime of x is equal to 15x minus 20 minus 15x minus 21 over 3x minus 4 quantity squared. I'm going to highlight the positive 15x and the negative 15x, and I'm going to draw red lines through them to show that I'm canceling those out because those add up to 0. Now we get p prime of x is equal to negative 41 over 3x minus 4 quantity squared, and this is going to represent my derivative function, so I'm going to go ahead and box that in. Example 3. Find the derivative in simplest form. Here we have g of t equals 4 plus 3t plus 2t in the numerator all over t cubed plus 5. On the right-hand side of the function, I'm drawing an arrow to the numerator and labeling it as u, and an arrow to the denominator and labeling that as v. And then to the right of that, I am writing the quotient rule for derivatives. The derivative with respect to x of u divided by v is equal to v du minus u dv, all divided by v squared. So g prime of t is going to be equal to, I have drawn a large enough fraction bar so that everything fits here. In the numerator, I'm going to write t raised to the third power plus 5 inside parentheses times the quantity 3 plus 2t. And then from that product, I'm going to subtract 3t squared times the quantity 4 plus 3t plus t squared, all over t raised to the third power plus 5 quantity squared. So g prime of t is going to be equal to, if I multiply everything in the numerator out, I'm going to have 2t raised to the fourth power. I'm going to have 2t raised to the fourth power plus, I'm going to have 2t raised to the fourth power plus 3t raised to the third power plus 10t plus 15 minus 12t raised to the second power minus 9t raised to the third power minus 3t raised to the fourth power all over t raised to the third power plus 5 quantity squared. So this is going to give me g prime of t is equal to, I've highlighted in yellow my terms that have t raised to the fourth power. So I highlighted in yellow the 2t raised to the fourth power minus the 3t raised to the fourth power. And I've highlighted in blue the 3t raised to the third power and the minus 9t raised to the third power. So I'm going to combine like terms. This will leave me with negative t raised to the fourth power minus 6t raised to the third power minus 12t squared plus 10t plus 15 all over t raised to the third power plus 5 quantity squared. I'm going to box that in. Example 4. Find the derivative in simplest form. We have the following function. P of x equals, open up a set of parentheses, 4 times radical x. Outside the radical we have plus 3, then we close the parentheses, times, open up a set of parentheses, 2x minus 5, close the parentheses. I'm going to label the first factor as u and the second factor as v. And then I'm going to write down beneath, right where it says example 4, u times dv plus v times du, which is the product rule for derivatives. So p prime of x is going to be equal to, first I'm going to write down u, which is the 4 radical x plus 3 part inside parentheses, and then I'm going to multiply that with the derivative of the 2x minus 5, so that's just 2. And then I'm going to add to that product inside parentheses we have 2x minus 5 times, and then this is the derivative of u, so this is going to be, I'm going to write over here on the right hand side, u equals 4 radical x plus 3, and then I'm going to rewrite that as u equals 4x raised to the 1/2 power, and then plus 3. So du will be equal to 4 over 1 times 1/2 x raised to the 1/2 minus 2/2 power. And so if I simplify that out, du will be equal to 4/2 x raised to the negative 1/2 power. So du is equal to 2x raised to the negative 1/2 power. So that is what I'm going to replace for my du part. I'm going to write 2x raised to the negative 1/2 power and then close the parentheses. Now we simplify this. So p prime of x is going to be equal to 2 times 4 is 8, so it's going to be 8 radical x. And then plus 6, because 3 times 2 is 6, plus 4x raised to the negative 1/2 power plus 1. So that's going to give me, and then 4x raised to the 2/2 power plus 1/2 power minus 10x raised to the negative 1/2 power. P prime of x will be equal to, if we simplify this a little further, we're going to get 8 radical x, or we're going to get 8x raised to the 1/2 power plus 6 plus 4 plus 4x raised to the 1/2 power minus 10x raised to the negative 1/2 power. So p prime of x will be So p prime of x equals 12x to the 1/2 power plus 6 minus 10x raised to the negative 1/2 power. And I'm going to box in that derivative function. Example 5. Application. The witch of Agnesi is a curve. The witch of Agnesi is a curve studied by mathematicians for its interesting properties. Consider the function f of x equals 8 over x squared plus 4. Part A says graph this function. On the right-hand side of the screen, I'm going to draw a coordinate plane. On the x-axis, I'm going to draw in tick marks from -3 to 3, separated by a scale of 1. On the y-axis, I'm going to go from 0 to 3 by a scale of 1. I'm going to write a table here in between the function and the graph. The first column is going to represent my x values, and the second column represents my f of x values. If x is equal to -2, f of x equals 1. If x equals 0, then f of x equals 2. And if x equals 2, then f of x is equal to 1. If x equals -2, then f of -2 is equal to 1. If x equals 0, then f of 0 is equal to 2. If x equals 2, then f of 2 equals 1. I'm going to plot these points on my graph, and then I'm going to connect these points by the curve of the function. So it's a function that is in quadrant 2 and in quadrant 1. As the x values go out to -infinity, the graph becomes asymptotic with the x-axis. And as the x values go out towards positive infinity, the function becomes asymptotic with the x-axis. I have labeled in my points with their corresponding ordered pairs. So I labeled in the -2, 1, 0, 2, and 2, 1. B. Find the equation of the line tangent to the curve when x is equal to 1. F of 1 equals 8 divided by 1 equals 8 divided by 1 squared plus 4, which is equal to 8 over 1 plus 4, which equals 8/5. I've drawn an arrow pointing to the right, and I have written this as an ordered pair, 1, 8/5. F prime of x is going to be equal to, inside parentheses, we're going to have x squared plus 4, and that's going to get multiplied with 0, minus 8 times 2x, all over x squared plus 4 quantity squared. So f prime of x is going to be equal to -16x over x squared plus 4 quantity squared. So if I want to find f prime of 1, which is going to provide me the slope of the tangent line at x equal to 1, this is going to be equal to -16 times 1 over 1 squared plus 4 quantity squared, which is equal to -16 over 5 squared, which will be equal to -16 over 25. So this is going to represent my slope. I have a point, I have the slope. I can now use point slope form, which is y minus 8/5 equal to -16 over 25 times the quantity x minus 1. And I'm going to box in that equation. This is the equation that represents the line tangent to the curve when x is equal to 1. Part C. Find where the curve has a horizontal tangent line. If we have a horizontal tangent line, that's going to be a tangent line where the slope is equal to 0. We find the tangent line by using the derivative. So I'm going to have to make sure I set my derivative equal to 0. I have underlined the words horizontal tangent line, and underneath that I have written m equals 0 because I know this is where the slope is equal to 0. And now I have written down my derivative function, f prime of x equals negative 16x over x squared plus 4 quantity squared, and I have set this equal to 0. Now I need to solve this equation. So I'm going to write negative 16x over x squared plus 4 quantity squared equals 0. In order to solve this equation, I'm going to multiply both sides by the LCD, which is x squared plus 4 quantity squared. On the left-hand side, the x squared plus 4 quantity squared is going to cancel out. And on the right-hand side, it's going to zero out. So we're just going to be left with a negative 16x equals 0. If I divide both sides by negative 16, I will be left with x equal to 0. So now that I found the x value where the curve has a horizontal tangent line, I can go ahead and write out at x equal to 0, the curve has a horizontal tangent line. And I'm going to box that in. I'm going to go ahead and I'm going to scroll up here back to the graph so that we can actually draw this in so it's easier for us to visualize this. I'm going to take my little column of values, my table of values, I'm going to lasso that and I'm going to shrink it. I'm going to move it more to the left. I have drawn a horizontal tangent line at x equal to 0 for you to be able to see this line here. And you can see here that the slope of this line is 0 because it is a horizontal line. I have drawn an arrow to my horizontal line and I am labeling this as the horizontal tangent line at x equal to 0. I have gone ahead and I've also labeled 1 on the x-axis. I've drawn a dashed line segment going up to the point where x is equal to 1. I have also drawn the horizontal tangent line at x equal to 1 so that you could visualize the line that is associated with the equation that we found for part B. I've drawn an arrow pointing towards that line, labeled it as the tangent line at x equal to 0, and I've also drawn an arrow from the equation that we found from part B to the line, because this is the equation that represents this line. And I'm writing next to that equation, the equation to this line. I am labeling the ordered pair at x equal to 1 with 1, 8/5. And this is an excellent visual for all of those visual learners who like to see pictures of what this looks like. Because this can be very abstract as you're finding these equations, finding these different values for x, and you might not realize what is it that I'm looking for, what is it that I'm finding. But by looking at this graph, hopefully this makes more sense why we're doing all of this. All right, let's move on to a business application. Average cost, average revenue, average profit. If C of X is the cost of producing X items, then the average cost per item is C of X divided by X. If R of X is the revenue from the sale of X items, then the average revenue per item is R of X divided by X. And if P of X is the profit from the sale of X items, then the average profit per item is P of X divided by X. Also, profit is equal to revenue minus cost. This is a very important formula. I put a cloud around it, I put a star next to it, and I wrote the word memorize next to it. Example 6. A company has found that the cost in dollars of producing X tables is given by C of X equals 800 plus 12X raised to the 0.6 power. The revenue for the sale of X tables in dollars is given by R of X equals 60X raised to the 0.7 power, or 7/10 power. A. Write the function that represents the profit from the sale of X tables. In order to do this, we're going to need to use the formula that we had mentioned earlier up above this problem. I put a cloud around it and I said you should memorize it. Profit equals revenue minus cost. I'm going to begin by highlighting in blue the word revenue in the formula profit equals revenue minus cost. I'm going to highlight the word cost in green, and then I'm going to go ahead and highlight in the problem C of x equals 800 plus 12x raised to the 6/10 power in green because that represents our cost. And I'm going to highlight R of x equals 60x raised to the 0.7 power in blue because that represents our revenue. I'm going to highlight the word profit in yellow from the formula and in the problem where they're asking us to find profit. I'm going to write down that formula, profit equals revenue minus cost, but I'm going to write it in the form P of x equals R of x minus C of x. Now let's go ahead and substitute everything that we know. Before I do that, let me actually move this formula to the right-hand side of the screen because I'm not going to have enough space to write everything I need to write here. So we're just going to move it over. Now I'm going to write P of x equals, instead of R of x, I'm going to write 60x raised to the 0.7 power minus, inside parentheses, we're going to write 800 plus 12x raised to the 0.6 power, close the parentheses. Now I'm going to distribute that minus sign. So if we multiply by a negative to the 800, that's going to give us minus 800. So I'm going to have P of x equals 60x raised to the 0.7 power minus 800. And then we're going to distribute to the 12x raised to the 0.6 power. So it'll be minus 12x raised to the 0.6 power. So this is going to represent our profit function. So P of x equals 60x raised to the 0.7 power minus 12x raised to the 0.6 power minus 800, and I'm going to box that function in. B, write the function for the average profit per item. This is going to be P of x divided by x, which is going to be equal to 60x raised to the 0.7 power minus 12x raised to the 0.6 power minus 800, all divided by x. And we're going to box that in. C, what is the total profit if 100 tables are sold? What is the average profit per item? So we're going to go ahead here and we're going to use the profit function first. P of x equals 60x raised to the 0.7 power minus 12x raised to the 0.6 power minus 800. Instead of x, we're going to substitute 100. So it's going to be P of 100 equals 60 times 100 raised to the 0.7 power minus 12 times 100 raised to the 0.6 power minus 800. And then we need to simplify this out. So this is going to be approximately equal to 516.94 or $516.94. The second part says, what is the average profit per item? So we just need to take the profit here that we got for 100 items and divide it by 100. Before I do that, let me go ahead and write right above the answer that I just boxed. Total profit if 100 tables sold. I'm going to draw a vertical line segment here on the right-hand side of the work that I just did. And here I'm going to start writing P of x divided by x is going to be equal to the average profit per item. So this is going to be P of 100 divided by 100, which is going to be equal to, I'm just going to go ahead and write 516.94 divided by 100 tables. So that means that this is going to be approximately equal to $5.17 per table. And this is going to represent the average profit per item. D, find the rate at which the average profit per table is changing when 100 tables have been built and sold. Compare this to the rate when 300 tables have been built and sold. I'm going to begin by writing the derivative with respect to x of u divided by v is equal to v du minus u dv, all divided by v squared. This is our quotient rule for derivatives. So I'm going to be using this rule to find the derivative. So the derivative with respect to x of p of x divided by x is going to be equal to x times, I'm going to open up a set of parentheses. Inside the parentheses, we're going to write 42x raised to the negative 0.3 power minus 7.2x raised to the negative 0.4 power, close the parentheses, minus, open up another set of parentheses, 60x raised to the 0.7 power, minus 12x raised to the 0.6 power, minus 800, and then we're going to close our parentheses, all over x squared. I'm going to distribute, in the first product, I'm going to distribute the x to all the terms. In the second product, I'm here distributing the negative. It's going to be the derivative with respect to x. It's going to be p of x divided by x is equal to, I'm going to draw a fraction bar. In the numerator of this fraction, I'm going to write 42x raised to the, I got to add 1 with that negative 0.3, that's going to give me 0.7 power minus 7.2x raised to the 0.6 power minus 60x raised to the 0.7 power, and then we have plus 12x raised to the 0.6 power plus 800 all over x squared. This is going to represent my derivative of my average profit function. I'm going to lasso all the work I just did here, and I'm going to shrink it, move it slightly to the left-hand side here. This is going to be equal to, once I simplify this, I have some like terms I can combine. I'm highlighting in yellow the 42x raised to the 0.7 power and the minus 60x raised to the 0.7 power. In blue, I'm going to highlight the negative or the minus 7.2x raised to the 0.6 power and the 12x raised to the 0.6 power. If I simplify, I'm going to get negative 18x raised to the 0.7 power plus 4.8x raised to the 0.6 power plus 800 all over x squared. So now we are going to find the answer to this if we evaluate this at x equal to 100. So we're going to find here the derivative with respect to x of p of x over x, and we're going to evaluate this at 100. So this would be the notation that what this would look like basically if we were to put this into the graphing calculator and find the numerical derivative. Or you could also just evaluate this at the function that I wrote up above, which I just simplified. This is going to be approximately equal to $0.042 per table. When 100 tables have been built and sold. The average profit is increasing by 42 thousandths of a dollar per table for every additional table built and sold. So that's basically what this means. That's what we found right now when we found the rate of change. I'm going to go ahead and box that whole thing in. Now I'm going to write here the derivative with respect to x of p of x divided by x, which represents our average profit function. We're evaluating this at x equal to 300. This is going to be approximately equal to negative $0.000317 per table. So this now represents a negative rate of change. And what this basically means that when 300 tables have been built and sold, the average profit is, in this case, it's decreasing by this amount. So when 300 tables have been built and sold, the average profit is decreasing by $0.000317 per table for each additional table built and sold. And I'm going to go ahead and box that in, and that's going to be our answer for this problem.